everyone. I'm going to go through how to do the Phys 140 Kirchhoff's Law Lab. So in class, I had you fill out this pre-lab worksheet, and in that worksheet, you calculated the expected currents through each branch of the circuit. We're going to measure the voltage across each resistor in each of these pre-lab setups so that we can use Ohm's law to calculate the experimental value of the current through the resistor. I also have this little worksheet with tables so that we can fill in the resistance of each resistor, the voltage drop across the resistor, and the experimental current, and then compare it to our theoretical using a percent error. Okay, so the first thing I've done is set up the resistors on this pegboard. The resistors are color-coded to show what value they have. So this yellow one here is the 470 ohm resistor, which is at the top, looks more like this, so at the top of this circuit. And then we have the 220 ohm resistor beside it, and then the two 100 ohm resistors here. So that's 100 vertical and 100 horizontal. So I've just set them up in an orientation that's similar to what is on the pre-lab handout. And very first, I want to determine the resistance of each resistor. So this gray multimeter here can be used to find any electrical measurement, and this time I'm going to use it to find resistance. So I have these leads, one into this ohms outlet and one in the ground. So I'm going to put one on either side of the resistor. When we're connecting a multimeter to measure resistance, we don't want anything else in the circuit, just the resistor. And then I'll hit the ohms button here. Okay, and that one's 220.67 ohms, and I'll write that down. And then move this to the 100 ohm resistor here, 98.23. The vertical 100 ohm resistor, 99.02. And this 470 ohm resistor here. So this one is giving me 463.1 ohms, or 0.4361 kilo ohms. All right, so I filled in all the resistance values. We need to do that first. They will be the same on the back side of the circuit since I'm going to use the same resistors again. Have to be careful to get the right 100 ohm resistor to match my table. Okay, so now I'll connect the circuit. This I'll leave to the side for a second since it will become our voltmeter. I'm going to be careful to connect the power supplies in the same way that we have here. So I want the positive terminal of one power supply to connect to the 220 ohm resistor, while the negative starts at the 100, and my other power supply is going to connect between these two resistors. Between the resistors, I'll use these small wires to connect them. So let's first use our voltmeter to set our power supply to the right value. I'm just going to take the alligator clips off for a second and plug it in here. And this one will connect to my 470 ohm resistor here. So I'm going to make that 2.5 volts. Turn it on, and then I hit volts. It's at 4, so I need to turn it down quite a bit. Okay, that's pretty close, so maybe I'll stick with that. 2.5527. See if I can get it a little bit closer. Okay, that's better. So 2.5100 volts. Great, and then I'll put in my other wires to connect to the circuit. So one into the negative terminal and one in the positive terminal. And I'm connecting my positive terminal to the 100 ohm resistor and the negative terminal to the 470 ohm resistor as per the circuit diagram. Okay, let's set up this power supply here. There we go. So I'm going to plug in to both outlets and set this one as close as I can to 4 volts. So it needs to come down. Oh, I was almost there. 4.32. We'll leave that. 4.133 volts. Okay, so now I'm going to remove that and connect our secondary wires. I'll need clips on both of these wires. I have them. Okay. And then my positive terminal goes to the 220 ohm resistor and the negative connection to the 100 ohm resistor. Okay, so I've got that set up. And now little wires are going to make the intermediate connections. So here, these conducting wires, and I'll need 2 at the top here to connect to the center path. All right, that's all set up now. Everything's on. So I'll be measuring the DC voltage here, which is already measuring volts, as I probe each resistor. I'm going to clip them on the side of each resistor and measure the voltage drop across the resistor. This works well for a voltmeter because it needs to be connected in parallel, so I can connect it to its own path to each resistor, and then it measures the voltage drop through that resistor. So in this case, for this 100 ohm resistor, I have negative 1.1204. Okay, let's check the 220 ohm resistor. This one's 2.5232. So I'm getting a negative sign only because I reversed the direction of my terminals. So you can see here that if I have them flipped for that previous one, it now gives me a positive value on that horizontal resistor. Okay, let's check the vertical 100 ohm resistor. So 0.7917. And then lastly, this 470 ohm resistor here. 2.5098. Okay, I'll pass on this data to you and you can check for me. We're going to do Ohm's law to find the experimental current, and then the percent error here using our theoretical current from the pre-lab as the accepted value. And underneath there's some space for you to do the sample calculations. All right, so I'll just turn this off for a second and we can set up the second circuit. So for this circuit, I'm going to keep my vertical 100 ohm resistor. So I'll write that value in here. The vertical 100 ohm resistor was 99.02. And then the other 2 resistors will have the same value, the 220 ohm and the 470 ohm resistor. So following this setup here, I'm going to put 220 ohms, 100, and then 470. Just in a line like that so that it matches the diagram. And then looking here, I have both power supplies on one side, the 2.5 volt power supply, which was this one. I'm going to connect it so that my negative terminal goes to the 470 ohm resistor, and the positive terminal connects to the middle path, which is to that 100 ohm resistor. This was my 4-volt power supply, approximately 4 volts. So I'm going to connect the negative terminal to the 220 ohm resistor and the positive terminal also to the 100 ohm resistor in the center. All right, on the other side, I'll use these small connecting wires to connect the rest of the circuit, which looks like this. Great. So now we can just measure again the voltage drop. Let's put that back on across each resistor. Caught. All right, so let's start with this 470 ohm resistor. Oh, of course, turn that on. So when we measure this voltage, I have 0.3978. Drop my pencil. Okay. I'm going to record that. That was 470, 0.3978 volts. Now we'll go across the 100 ohm resistor here in the middle, just connecting them on top there. That's giving me 1.2160. And lastly, this 420 ohm resistor, 2.9061. Okay, and that's it for the experimental part of the lab. So you can fill in the rest, the experimental current, the percent error, and then in the bottom I have 2 questions for you. So one is that I would like you to select one loop from this circuit, this part B here, so either the bottom loop, the top loop, or maybe the outer loop, and verify 2 rules. So check for one, that your junction rule holds. You can pick any junction to do that, and use a percent error or a percent difference to do that. So compare your currents into the junction to your currents out. We know that they should be equal because of Kirchhoff's junction rule. And then when you choose the loop, verify that the sum of the potential differences around the loop add to 0. For that, you can use the sign convention that you've chosen based on your loop direction and your current direction to check that those voltages give you 0. This is an experiment, so think about how close it is to 0 and if you think that that does make sense with the error in the lab. As for sources of error with this lab, the main source of error is the resistance outside of these fixed resistors. So if we assume this is an ideal circuit, then all of the resistance is concentrated in each one of these fixed resistors. However, we know from in class that conducting wires also have resistance. Resistance in conducting wires is called line resistance. Though these are fairly short, they would have some amount of resistance, and there would also be some amount of resistance within the ammeter or the voltmeter and the power supplies. So in that case, if it's in a power supply, it's called internal resistance. And so those 2 sources of error may be affecting our results here. Okay, that's all for today. Let me know if you have any questions.